are going to discuss about FET transistor, its biasing. So as we discussed in a PNP and NPN transistor, what is biasing? Biasing, that means if you apply there battery or DC supply, that means it is biasing. So here in this topic we are going to apply biasing techniques. So this is the FET biasing. So here we can see there are different types of biasing circuits for JFET, which are, we can see here, number 1, fixed bias circuit, which is also called as gate bias, number 2, self bias circuit, and number 3, voltage divider bias circuit, which is also known as VDB circuits. So we are going to discuss about its regions of operation. So number 1, we can see cutoff region. So its application is as an open switch. Number 2 is saturation region, and its application is as an amplifier. And number 3 is ohmic region, and its application is as a closed switch. So that means we are going to biasing this FET in this types and discussed about its stability. So let us start with first self bias, or it is called as gate bias circuit. So here we can see this is the self bias or gate bias circuit, and below this here we can see this is the circuit diagram of gate bias. So here we can see at gate side VGG is connected, which is battery, and here plus VDB, and here we can see this is the source, which is grounded. Now we have to apply KVL at the output side. Here we applied KVL at the output side. So what happened? That means VDD minus IDRD minus VDS is equal to 0. Now here we have to common or subject VDS, because VDS is the output of the FET. So subject VDS is equal to, what happened? VDS is equal to, it becomes VDD minus IDRD. So here this is the gate bias, and it is the worst way of biasing in active region, because the Q point with this biasing is extremely unstable. So we are not going to use gate bias or fixed bias circuit because it is unstable circuit. So there may be a distortion generated in the circuit diagram. So we are going towards number 2. It is known as self bias circuit. Now for self biasing configuration, which eliminates the need for 2 DC supply. Here we can see this is the circuit diagram of self biasing. So slightly changes here, but we are going to discuss an analysis at the DC end. So DC analysis, capacitor C1 and C2 will be open circuited. If we are going to analyze in the form of DC, so there not should be any capacitor in this circuit diagram. And here we can see RG, which is gate resistor, which is replaced by short circuit, because here we can see if we open C1, that means your IG gate current is equal to 0. If your gate current is equal to 0, then here your RG becomes shorted. Now solve it with the mathematical expressions. So step number 1, obtain VGS. VGS always obtain from the input side, and VDS obtain from the output side. So simple, apply KVL in this simplified DC equivalent circuit. So what happened? That means VGS plus IDRS is equal to 0. So VGS is equal to minus IDRS. Here VGS is not a fixed voltage, but it is a function of output current ID. Here we can see VGS plus to minus, that means minus VGS here, plus minus, that means minus RS IS, but here IS is equal to ID. So we can write ID instead of I. ID instead of IS. So this is the step number 1 from which we will get about VGS. Now step number 2, obtain expression of ID. Now we will get ID's equation by the use of Shockley's equation. Shockley's equation is like this: ID is equal to IDSS in bracket 1 minus VGS upon VP bracket complete whole square. So this is the Shockley's equation. Now substitute VGS equation in this equation. So it becomes ID is equal to IDSS in bracket 1 minus ID into RS upon VP bracket complete whole square. Now here minus minus becomes positive. So here ID is equal to IDSS in bracket 1 plus ID RS upon VP bracket complete whole square. So this is the expression of ID, or we can say expression of drain current. Now step number 3, obtain expression for the VDS, which is at the output side. So simple, we have to apply KVL at the output side. So here we are going to start with VDD. So VDD, current flowing in this direction. So VDD minus IDRD minus VDS minus IDRS is equal to 0. Now here we can see in this equation we applied Q, that represent Q point. So we can write this equation: VDD is equal to IDQ into RD plus VDSQ plus IDQ into RS. Now is equal to common IDQ, that means IDQ common in bracket RD plus RS plus VDSQ. Now here we have to subject output, so VDSQ should be subject here. So VDSQ is equal to VDD minus IDQ in bracket RD plus RS. So this is the expression for the VDS. Now the latest circuit, and we are mostly used in amplification, which is known as voltage divider bias circuit. So here we are also using DC analysis. So all the capacitors are open circuited and IG becomes 0. Furthermore, IDD is divided into two equivalent sources. And also we can see here in this circuit diagram, these resistors are divided into R1 and R2. So this becomes voltage divider bias. Now here DC analysis, similarly we are going to analysis from the input side and final at the output side. So step number 1, obtain the expression of VG. It is the resistor across R2. Now step number 2, obtain VGS. Apply KVL to the gate source side. Now what happened? VG minus VGS. Now what is VG? VG is the point between the R1 and R2 resistor. That node is known as VG. Now VG minus VGS minus IDRS is equal to 0. Now we have to find expression of VGS. So we should take subject VGS. VGS is equal to VG minus ID into RS. Now next, step number 3, obtain VDS, and we will get VDS at the output side. So simple, we have to apply KVL at the output side. Now we will start with VDD, and going further this anti-clockwise direction. So what happened? VDD minus, it goes minus IDRD, here first positive sign, and we have to take minus VDS, here minus IDRS is equal to 0. Now we have to find the expression of VDS, so we should take VDS as a subject. VDS is equal to VDD minus IDRD minus IDRS. So it becomes VDD minus ID common, RD plus RS. So this is the final expression of VDS. So drain to source voltage, gate to source voltage, and drain currents equation we have to find, we have to derive for its stability and for its Q point. Then and then we will get precise output at this output side. So that's all for today's lecture. If you have any query related to this topic, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in next coming lecture. Thank you.